Why do humans have fingerprints? The answer is not what you think. Look at the tips of your fingers. Press one against a clean surface and lift it away. You will leave a mark, a tiny, perfect record of yourself. Loops and whorls and arches pressed into the world wherever you go. You have been doing this since before you could walk, since before you were born, and you have probably never once asked why. Most people have an answer ready if they do think about it. Grip. Fingerprints help you hold things. They give your skin texture so objects do not slip. It sounds obvious. It sounds correct. It is the kind of answer that feels so logical you stop thinking the moment you reach it. The problem is that when scientists actually tested it, the obvious answer did not hold up the way everyone expected. And the real answer has been sitting on the tips of your fingers your entire life, doing something far more interesting than keeping objects from sliding. So why do humans have fingerprints? The real answer is stranger than grip. And it begins not with evolution, not with tools, not with anything you can hold in your hand. It begins before you were born, in the first few months of your existence, when your body was still deciding what shape to take. Fingerprints are not painted onto your skin. They are not a surface feature added late in development, the way hair or nails are. They grow from inside the skin itself, from the boundary between two layers. The outer layer and the inner layer of developing skin grow at slightly different rates during the first trimester. That difference creates stress. And when biological tissue is under stress, it buckles, it folds, it forms patterns. The same mathematics that creates ripples in sand, stripes on a zebra, and spots on a leopard also creates the ridges on your fingertips. Not because your body planned those specific patterns, because physics and biology together produce them under pressure, following rules that have nothing to do with identity or grip or anything a human being would consciously design.
That is why no two fingerprints are identical, not even on the same hand. Not even between identical twins who share every strand of DNA, because the exact pressures and positions and movements inside the womb during those weeks of development are never perfectly repeated. Your fingerprints were not assigned to you. They were not inherited like eye color or blood type. They emerged from chaos, from the random pressures of a body forming in a small, moving, fluid environment. By the time you were born, the patterns were already permanent, and they will not significantly change again for the rest of your life, barring deep scarring. Even then, they often grow back the same way. But that still does not answer the deeper question. Why do humans have ridged skin on their fingertips at all? If evolution kept fingerprints around for millions of years across the entire primate family, they must be doing something useful. Random traits that cost the body nothing can persist without a function. But traits that require a complex developmental process tend to survive because they solve a problem. So what problem were fingerprints solving? And for most of scientific history, the answer everyone assumed was grip. The logic seems solid. Ridged skin creates more surface contact than smooth skin. More contact means more friction. More friction means better grip. A hand that can grip is a hand that can climb, carry, hold tools, and survive. It is the kind of explanation that fits so neatly into common sense that it became the default answer in textbooks, in museums, in every casual explanation anyone ever offered. Simple, clean, convincing, and it went largely untested for a very long time. Then researchers at the University of Manchester decided to measure it properly. They built a device to test how fingerprint ridges actually performed against smooth surfaces under controlled conditions. They measured the friction. They measured the contact area. They tried to confirm what everyone assumed was already confirmed. And what they found was uncomfortable for the grip theory. In many conditions, fingerprint ridges did not significantly increase friction the way the theory predicted.
In some conditions, the opposite appeared to be true. The ridges reduced the total contact area between skin and surface compared with what smooth skin would provide, which is not what you want if your primary goal is grip. That does not mean fingerprints do nothing. It does not mean grip is entirely irrelevant. It means the explanation was probably too simple. It means the story that felt finished was not finished.
And it means the real reason may have been hiding in plain sight all along. Not in how your fingers hold things, but in how your fingers feel things. Touch is not one sense. It is several running at the same time. Your skin can detect pressure, texture, vibration, temperature, and pain through different types of specialized nerve endings distributed across the body in different densities. And the fingertips are one of the most nerve-dense regions of the entire human body, packed with receptors designed to pick up fine information from the world. When you run a fingertip slowly across a surface, you are not just touching it, you are reading it. The ridges of your fingerprint may amplify that signal. They may help the skin vibrate in response to tiny surface textures in a way that smooth skin could not replicate. Think of it like the grooves on a vinyl record. The groove is not the music, but without the groove, the needle cannot read what is embedded in the surface. Fingerprint ridges may work as biological amplifiers for the sense of touch, channeling vibration toward the nerve endings beneath the skin so the brain can receive richer, more detailed information about whatever the hand is contacting. One research team found evidence that fingerprint ridges dramatically increase the sensitivity of a specific type of nerve ending called the Pacinian corpuscle, which is specialized for detecting fine vibration and texture at low amplitudes. When the ridges are present, those receptors appear to fire more strongly in response to subtle surface variations than they would against smooth skin. The ridges do not just touch the surface, they interact with it in a way that generates more signal for the nervous system to work with. That means your fingerprints may not primarily be helping you grab the world. They may be helping you read it.
And that would make deep sense for a primate. Primates are unusual among mammals for how heavily they rely on their hands, not just for power and grip, but for precision, for picking up small objects, for manipulating things carefully and deliberately, for feeling whether a fruit is ripe, whether a surface is safe, whether something small is hidden in fur or grass or soil. A hand that can detect fine texture and subtle vibration is not just a tool for holding, it is an instrument for understanding the physical world at a level other animals cannot access. And over millions of years, even small improvements in fingertip sensitivity could matter in ways that ripple through survival, feeding, tool use, and social behavior. Other primates have fingerprints too. Chimpanzees, gorillas, and orangutans all have ridged skin on their fingertips and palms. But the most striking example comes from outside the primate family entirely. Koalas, marsupials with no close evolutionary relationship to humans, also have fingerprints. And not just vaguely similar ones. Their ridge patterns are close enough to human fingerprints that they have occasionally appeared in forensic contexts and caused confusion. Koalas evolved ridged fingertips independently, on a completely separate branch of the animal family tree, for their own reasons related to gripping and feeling bark and leaves, which suggests that ridged skin on grasping, sensitive digits is not a quirk of one lineage. It is a solution that evolution discovered more than once, in more than one place, because the problem it solves is real. Because that is the strange epilogue to this story. Fingerprints became famous for something entirely unrelated to why they exist. For most of human history, no one thought about fingerprints as personal identity. They were just skin. The observation that fingerprint patterns are unique and permanent and could therefore be used to identify individuals only became a formal system in the late 19th century. Francis Galton collected and classified thousands of them. Police forces began building records. Courts began accepting them as evidence. And eventually, fingerprints became one of the most recognized symbols of individual identity on Earth. Every crime drama, every spy film, every border crossing, every smartphone screen.
But evolution did not build fingerprints for identification. It did not build them for forensics or security systems or locked phones. It built them, if the sensory amplification theory is correct, to help a primate hand feel the world more clearly. The uniqueness was a side effect of chaotic development, not a design feature. The identity came later. Humans took a biological outcome that nobody planned, a pattern produced by random mechanical stress inside a womb, and turned it into the most personal proof of who you are. There is something quietly strange about that. The most individual mark on your body was not chosen. It was not assigned. It was not inherited the way a family resemblance is inherited. It formed in the first months of your existence from forces too small and too random to ever repeat. Two people with identical DNA, raised in the same womb at different times, will have different fingerprints because the pressures of development are never perfectly duplicated. The patterns came from chaos, not from a plan. Every fingerprint is a record of a body forming under pressure. Literally, the loops and whorls on your fingertips are the trace of biological stress, of skin layers growing at different speeds, of tissue responding to its own physical tension during a few weeks of development that you will never remember. You did not generate those patterns consciously, but you generated them, alone, in motion, in the dark, before you had a name or a face or a single memory. And you have been pressing them into the world ever since. So why do humans have fingerprints? Probably not mainly for grip. Most likely for touch, for reading surfaces at a level of detail that smooth skin could not manage, for giving a primate hand the sensitivity it needed to feel what it could not always see, for turning the fingertip into something closer to an instrument than a blunt tool.
The patterns themselves came from physics, from the mathematics of buckling tissue and uneven growth and random mechanical pressure during development. The uniqueness came from the irreducible chaos of a body forming in a womb. And the meaning humans gave them, the identity, the evidence, the proof of self, came from something else entirely. From a species that is very good at finding patterns and deciding they mean something. You carry those patterns everywhere, on every surface you touch, a record of forces that acted on your body before you existed as a person, before memory, before language, before any story you could tell about yourself. Your fingerprints were the first thing about you that was completely your own, and they were never really a choice. If you want to keep asking questions like this one, questions about the strange biology buried inside ordinary human things, subscribe. There is a lot more written into this body than most people ever think to look for.